Okay, so I'll start now with one-sided limits. Okay, of course, kanina, when I mentioned to you that when you say that x approaches a, you can approach that value a, in this case, this a, from the right or from the left. So when I say you approach a from the right, we mean to say for all x values that are greater than a. Of course, I'm following the ordering in the real number line. To the right are large values greater than a. To the left are smaller values. So when you say approaching a from the right, we mean to say these values of x's that are greater than a going to a. And then the other one is from the left, smaller values than a and then going to a. And of course, now our problem is to look at the behavior of a function one-sided, from one side only. So when you say limit from the right, this is the notation. The limit of a function as x approaches a, this a with this addition symbol as the exponent is called, or a superscript is called, as read as x approaching a from the right, from the values of a that are greater than a. And then this other one is from the left, from the values of x that are less than a. Okay? And what we mean by this limit from the left is to simply look at the behavior of the function, just simply looking at the right-hand side of a. And then from the left, we'll just be looking at the left-hand side of a. Okay? So those are what we mean by one-sided limit. Rather than immediately looking at from both sides, we simply look at the limit from the right or the limit from the left. But still the question is, meron ba tayong na-approach na specific value that is as a specific limit from the right and from the left? At kung merong from the right saka from the left, what do this thing tells us about the actual limit of the function as x approaches a? Kumbaga, from one-sided, what can we say about the so-called naman two-sided limit? Yung ginawa natin kanina prior to the lunch can be called as a two-sided limit. We are immediately considering limit from the right and from the left. Pero ngayon, ang gagawin naman muna natin, one side lang muna. Okay, so again, these are the notation. Okay, the first one is the limit of a function as x approaches a from the left, a to the negative. And the other one is the limit of the function as x approaches a from the right. Again, this minus and plus are just for notations. Negative indicates from the left, and then this plus indicates from the right. Not really arithmetical operation, more on just really notation. Okay? Of course, there are formal definitions. I will just be showing to you now and just highlight some minor differences. This is the definition of a limit of a function from the right. Okay. I know, again, some of you, first time na na-encounter kanina yung epsilon delta definition, but then if you're going to go over this definition, ay, hindi pala ito from the right, sorry, nagsimula pala ako ay from the left. Okay, I do apologize. Okay, so there are some differences. First, yun sa preliminaries natin, look at that. The function is defined on some interval of the form CA. Tandaan niyo yung kanina sa two-sided limit, sa ating limit of a function. The function should be defined on an open interval containing A except possibly at A. But then for limit from the left, we only want an open interval where from the left of A. That's why you have this open interval C to A. Kumbaga, going to the previous illustration, from the left ako nagsimula, ano? Kumbaga, ang kailangan lang muna natin sa from the left, kuha ka ng isang interval from the left of A. Okay? So ito lang muna yung concern natin, some interval from the left of A. From the left ako nagsimula. Okay. So yun yung unang requirement. From the left lang mong tayo. Unlike kanina, dapat an open interval containing A na kaagad from the left and from the right, it is already defined. From this one, from the left lang muna tayo defined. But then if you're going to follow the whole definition, it's very similar to the two-sided limit except for this one. Okay? Napansin nyo? Dun sa original definition natin, this is absolute value of x minus a. However, for this specific limit from the left, ang requirement lang natin is a minus x. Okay? A minus x. And that should be greater than 0. Okay? Again, the idea behind that is just we are considering excess from the left. And then if you're going to consider excess from the left, we mean to say values that are less than A. Tama, di ba? Pag pinag-usapan natin ay values of excess from the left, all the excess here are less than A. Okay, and that's why if you're going to go over the limit definition, limit from the left, a minus x lamang because that will guarantee that a minus x will be greater than 0. Bakit? Because all the x's from the left are less than a. So a minus a value that is less than a, automatically that is greater than 0. Okay? So that is the major difference. You only consider values from the left. Wala ka na munang pakialam from the right. But it's still, in the whole definition, it's the same as what we had a while ago for the case of a limit of a function. That's why pag pupunta tayo sa limit from the right, ito naman yung mangyayari sa limit from the right. Una muna yung open interval. This time, the open interval is, look at that, AC naman siya, from the right of A. Let me go back again sa illustration natin kanina. Ito naman yung kailangan nating interval ngayon. Interval of the form AC. Dahil kasi, ito naman yung kailangan natin. The function should be defined from the right, so there should be some open interval of the form AC or values of x from the right of A. Okay, continue. Yun yung first major difference. And then next, you look at this. Dun sa limit from the left, a minus x, because we are guaranteed the x's from the left of a are less than a. Ngayon naman, tingnan nyo, x minus a naman siya. Bakit naman siya x minus a? Because we want the values of x from the right of a naman. And then, syempre, kapag from the right, the values of x from the right of a are greater than a. So, x is greater than a, x minus a will be greater than 0. But then all the rest, notice, are basically the same as our original limit definition. Okay? So talagang ginawa lamang ng one-sided limit ay naging bias lamang siya over one side. Limit from the left lamang siya, limit from the right. And even the definition, in the definition, it will follow that one-sidedness of the limit. Okay? So we will go over again the epsilon delta activity for this one. I think enough na yung kaninang umaga. But then bakit nga ba kailangan itong one-sided limit? Because one thing is for some type of function, it's best to first examine one-sided limit before we proceed with the actual limit of the function. What do I mean by that? It's because of this result. Okay. That for us to have a limit of a function, ito pong nauna is the original, the limit of a function as x approaches a is L. This will only be true if and only if. For those who have background in theorems in math, when we say if and only if, these are biconditional statement, meaning this will only hold if and only if this is satisfied. So this should be satisfied before this will hold. It's a necessary and sufficient condition. So pwede ka lang palang magkaroon ng actual limit, the limit of the function as x approaches a is L, if and only if we have one-sided limits, limit from the left of a, limit from the right of a, and the two limits are equal. So yung palang ginawa talaga natin kanina sa morning ay talagang two-sided limit kaagad siya. And the only way for a two-sided limit to exist is if and only if both the left and the right, limit from the left and limit from the right, they both exist, and also they are equal. Okay? Another way of looking at that, every two-sided limit or every limit problem can be broken down into two. A limit from the left and a limit from the right. Okay? So, and then the two should be equal so that you can get the limit of the function. In the examples this morning, we do not need one-sided limit because, again, the nature of the function. Because we only have a single expression that describes the whole function. But then for our examples this afternoon, as we will see, there are functions that really have different behaviors from the left and from the right, and they are defined accordingly. Magkaiba rin yung definition from the left and from the right. Okay? So kindly remember this because we will need this for our going on to the topic about continuity, the use of one-sided limits. Let me show you an example. Okay, so again, ang gagawin lang natin, observe the limit from the left and from the right, but still, it's the same activity. Kumbaga, we are going to trace some graph, we are going to compute for some limit, but then this time, one-sided lamang. Okay, look at this function. Some people call this as piecewise function because the function is defined piecewise. It's defined differently on one region and defined differently on another part. Or some people will also call this as a conditional function because you have two conditions. First condition, if x is greater than or equal to 0, this is the function value. If x less than 0, this is the function value. So you can use it alternatively. Piecewise function or pwede ring conditional function. Okay. But then for this one, the domain is the set of real numbers. But then what is quite interesting is to observe the property of this function at x equal to 0, or what is the behavior of this function going to x equal to 0. I hope you can still remember graphing conditional functions, because it will be very helpful for this one. But then a good thing is you can actually compute for the limit even if you do not graph the function. But then just be very careful. We want to look at the limit as x approaches 0. If I ask you limit from the left, what are you going to consider? Or if I ask what is the limit from the right of 0, what are you going to consider? Which of the two conditions? Let's start with the first one. If I'm going to ask you limit from the left, what is the indicator that it is the condition that you are going to choose or to use? If I ask you again, limit from the left of 0, we have two conditions. Saan papasok yung condition na limit from the left of 0? Is it the first one or the second one? Oh, thank you, Sam. Yan, maging specific kasi Sam. X less than 0. Like kasi sabi natin, limit from the left of 0, we are looking at values from the left. And definitely, the values from the left of 0 are those values that are less than 0. And also, kapag naman limit from the right, yun naman ay yung first one because we want values that are greater than 0. So at this point, gusto na kaagad natin sabihin that even if you do not know the graph of the function and if you want to solve problems involving one-sided limit, you can actually depend on the actual function on how they are defined. But then before we do that actual part, let's just first look at the graph. Okay? Para lang naman medyo visual muna tayo. Okay? So this is the graph of the function. From the left of 0, y equal to 2x plus 3. That's why you can see this line. Part of the line y equal to 2x plus 3, but then only for x less than 0. So that's why there is a hole there. Okay. And then the function from the right of 0 is x minus 1 squared. Y equal to x minus 1 squared. And it will be just a parabola. A linear function over the left, and then a quadratic function for the right. Okay. So if you are good in graphing, you can actually solve for the one-sided limits just by using the graph. Okay? Kaya kasi pwede yung gawin, pag tinanong kayo, ano yung limit from the left? So simply trace the graph from the left. Tama, no? And then the question is, what will be the value that it is approaching from the left? And that's it. And I think from this graph, I use GeoGebra pala sa graph na ito, kaya masyado maganda yung graphics with some bits of precision. If you're going to get the limit from the left, immediately, you can get the limit that is 3. However, if you're going to get the limit from the right, you have to trace this part. And then going here, makukuha naman natin limit from the right ay ito. Okay? So you really, if you are good in graphing functions, you can rely on the graph. But then again, let's be more precise, dahil kasi hindi naman sa lahat ng pagkakataon maganda ang mga kukuha nating graphs on our own. So now let us try to solve for the actual limit. Okay, so from the graph, you can get the values, but then again, sabi ko nga kanina, even if you do not know what is the graph of the function, okay, you can get the limit based simply on how the function was defined. Okay, let's start with the first one. Limit of the function as x approaches 0 from the left. According to some a while ago, we will have to consider for the first one, we have to consider the second condition. Tama, no? From the left kasi, so we want x less than 0. So wait, let me just change the color of my pen. Okay. So if you want to do that, tama, no? From the left, so for this one, the limit of f of x as x approaches 0 will be the same as the limit as x approaches 0 from the left. But then kunin lang natin yung from the left. And definitely, from the left, the function values are 2x plus 3. So that's why for this one, you can easily do it on your own. 2x plus 3. Okay, sorry. Oh, nagluloko yung pen ko. I mentioned that to you a while ago. Okay, sige. So limit of 2x plus 3 as x approaches 0 from the left. But then the good thing is 2x plus 3 is one of the nice functions that we have. Remember yung ating linear function? Linear functions automatically have two-sided limits. So wala tayong problem dito. So even if you go to one-sided limit, you can still perform quote-unquote substitution. Again, at this point, I'm going to call it a substitution because we already have the limit theorems. Okay? So I hope that is okay with everyone. I know sinabi ko kanina, nung simula, huwag natin kaagad gawing substitution at the start because really, those substitutions are results of the limit theorems. But then we already have the limit theorem. So at this point, I'm going to use the limit theorem. The limit of 2x plus 3 as x approaches 0 from the left is just simply, using the technique nga natin, this will just be equal to 3, which agrees with what we got from this graph. This one, going to 3. Okay? And now we go for the limit from the right. So definitely, ang limit from the right naman ay yung greater than 0. So you can easily do it. Wait, let me just change this. Limit as x approaches 0 from the right of this time, x minus 1 quantity squared. Okay? And once again, this is one of our nicer function, quadratic function. You can use, again, limit theorems, but then for simplicity, just call it a substitution, and we can get 1. Okay? And then again, that is consistent with what we have here from the graph. Yan. And then that will approach the value 1. Okay? So now, what will this tell us about the limit of our function as x approaches 0? Balikan natin yung ating result kanina. Ang sabi natin, okay. The limit of a function as x approaches a is L if and only if the limit from the left is equal to the limit from the right and both are equal to the same value L. So ano masasabi natin dito? What can we say about the limit of the function as x approaches 0? Anyone? Okay, thank you, Jasmine. So this is one of the class, not equal. The limit from the left is not equal from the limit from the right. So what does it tell us about the actual limit of the function? Yep, thank you, Miss Telma. Thank you, Jasmine. This is one of the example of a limit that does not exist. Okay, yeah, for short, DNE. But then, syempre, let's try to write it completely. Does not exist. Okay. The pen is already working now. Okay, sige. So this is an example of a limit that does not exist. So that is one indicator. If the limit from the left is not equal to the limit from the right, then the limit does not exist. Okay?